Today we're going to be looking at absolute value functions. Okay, if you remember from Algebra 1, an absolute value function is a V-shaped function. So all the graphs, all the equations that we're looking at today will be V-shaped graphs because we're looking at absolute value functions. All right, starting off, here are your state standards and your success criteria. All right, so you need to be able to describe the characteristics of an absolute value function from a graph. You need to be able to graph an absolute value function given its characteristics, and you need to be able to solve a real-life problem involving an absolute value function. One very important vocabulary word, vertex form. An absolute value function written in the form g of x equals a times the absolute value of x minus h plus k, where a is not equal to 0, is in vertex form. The vertex of the graph of G is HK. So you can see here that HK is going to be your vertex, okay? That's your turning point. HK, that's your vertex. HK, HK here. No matter where your V-shaped graph is, no matter what quadrant, HK is your vertex if it's in vertex form. All right, you can also see that if A is greater than 0, if this number is positive, greater than 0, it's going to open up. And if A is less than 0, it's going to open down. All right, it will never be sideways because if it were sideways, it would not pass the vertical line test, which means it would not be a function. So it has to be a V-shape or upside down V-shaped graph. All right, also one more thing really quick. An absolute value can be written in vertex form and its graph is symmetric about the line equals x equals h. All right, so remember HK is your vertex. The line of symmetry goes through the x value of the vertex. This is important because when you're drawing a V-shaped graph, if you have all your points on one side of the vertex, it'll look like a line instead of a V. So remember, you need to choose points on both sides of the axis of symmetry, which is going to be x equals h, whatever your h is. Example 1, describing characteristics. All right, this one says graph f of x equals the absolute value of x minus 4 minus 1. Determine when the function is positive, negative, increasing, or decreasing. Then describe the end behavior of the function. All right, so very quickly, let's remember what vertex form is. This is something hopefully you will commit to memory. Y equals a times absolute value of x minus h plus k. So hk is your vertex. So you can see the negative 4 is just going to be 4, and then the negative 1 is your k. So h is 4, positive 4, because the negative is part of the function. Okay, so 4, negative 1 is your vertex. All right, let's go ahead and graph that point. So it's going to be 1, 2, 3, 4, and down 1. All right, so that's my vertex. All right, so remember when I said you make a table of values, you get to choose points? Because what we're trying to do is we're trying to graph this function. All right, if we graph this function, we need to choose points on both sides of the vertex. So we know we have 4, negative 1 is our vertex. So if we want numbers below 4 or less than 4, we're going to have 2 and 3, 4, and then we need 5 and 6. So what that would do is give us 2 points to the left of our vertex and 2 points to the right of that vertex, so that we create the V-shaped graph. That's very important when you're looking at quadratics or absolute values, is that you get that symmetry so that you get to see the whole function. All right, now, how do you find the y value? You simply plug in x. Take x, each one, and plug it in to find f of x. F of x is the same as your y value. So let's take 2. 2 minus 4 is negative 2. The absolute value of negative 2 is 2. 2 minus 1 is 1. All right, do the same thing with 3. 3 minus 4 is negative 1. The absolute value of negative 1 is 1. 1 minus 1 is 0. All right, take 5, plug it in. 5 minus 4 is 1. Absolute value of 1 is 1. 1 minus 1 is 0. You can already start to see that symmetry there. And then 6 minus 4 is 2. Absolute value of 2 is 2. 2 minus 1 is 1. Now we have 4 more points that we can use to graph. So we're going to go over 2, up 1. We're going to come over 3 and put a point at 3, 0. And we're going to have a point at 5, 0. And another one at 6, 1. So you can see from the points that does create our V-shaped graph. All right, I don't have a V on here, so I'm going to have to create a V with 2 lines. All right, so now we have graphed f of x equals absolute value of x minus 4 minus 1. Now it says determine when the function is positive, negative, increasing, or decreasing. Then describe the end behavior of the function. All right, so let's first look at positive and negative. All right, so the x-intercepts are 3 and 5. So the function is positive for all values of x less than 3. So everything less than 3, it's above the x-axis. So we can say it's positive. For all values of x less than 3. All right, so positive means it's basically above this x-axis, okay? And again, this should be review from Algebra 1. I know it's been a couple years for most of you, but this should be review, so hopefully this is just jogging your memory. All right, where else is it positive? It's also positive for all values above this point here. Well, remember that was 1, 2, 3, 4, 5. So all values greater than 5. All right, so if it's positive here and here, that means it's negative only right here between these two. So we're going to say it's negative between 3 and 5. So we can say x is in the middle of these two numbers. Okay, so we can say 3 and 5. And we can say that x is between 3 and 5. Okay, so this basically says x is greater than 3 and x is less than 5, but this is just written with it in notation to where it's, because it's all one section here, we can write it like this so that it's just information is easier to understand. All right, also says when is it increasing and when is it decreasing. All right, so it's going to be increasing or decreasing when it's basically going up or down. All right, so the function is decreasing for all values that are less than 4. Okay, so even though this has an arrow going up, you read everything from left to right. So coming from left to right, this would be going downhill, so it would be decreasing for all values less than 4. So let's say decreasing for all x less than 4. That means it's increasing when it's going up. All right, when does it start going uphill? Well, it turns and starts going uphill at the vertex. The vertex is, we're just looking at our x values, so it would be all x greater than 4. All right, we don't really include the vertex as increasing or decreasing. That's just the vertex. That's kind of where it stops and turns and goes the other direction. So that's why it's not less than or equal to or greater than or equal to. It's just less than 4 and greater than 4 because we're only looking at where it's going downhill or uphill, which is increasing or decreasing. All right, the last thing it says to determine is the end behavior. All right, the end behavior is, I think, something that's pretty interesting, but a lot of people, I'm just going to put EB for end behavior. A lot of people struggle with this because they don't understand the domain and range. Right, so you spend a lot of time in Algebra 1 talking about domain and range and end behavior, but we are going to review this and we'll go through it. Several lessons you'll see things about domain and range and end behavior, and that's because it is something that you will see in every math class pretty much from here on out. All right, so the end behavior basically is saying, what does each end of the graph do? Okay, so what are we doing to the left? What are we doing to the right? All right, so we determine it from the domain and the range. So you have your x's that are going negative, you have your x's that are going positive, you have your y's that are going negative, and you have your y's that are going positive. So there's a lot of times it's going to be very simple. It's going to be one of those 4 things. So we can say as x, and this arrow just means approaches or goes in the direction of negative infinity, which in this case, x negative, remember this is your negative x's. If you're going left of 0, that's negative. This is right, this is your positive x's. As x goes negative, what happens to my y values? Well, it goes up, so that means the y's are going towards positive infinity. All right, now we're going to look at the other side of the graph. Okay, what happens when x's go positive? So we note that as x approaching infinity because that's your positive side. As x goes positive, what do the y's do? Well, it's going up as well. So your y's also approach positive infinity. So you're always going to have this. We're always going to go left or right. Depending on if the graph goes up or down on either side, these could change, but these are pretty much always going to be the same. But for this absolute value function, that would be your end behavior.